Now, guys, let us have a look at the question number 4 of today's contest. The question 4 was minimum cost to equalize array. What we are given with an array nums and two integers, cost 1 and cost 2. We can perform any of the two operations. That is, first of all, let me explain the question in short. We are provided with an array nums, and what we need to do is we need to make all the elements of this particular array equal to the equal. All the elements of this particular array should be equal. Now, for making all the elements equal, we can perform any of the two operations. The first operation can be, we can choose any of the index and we can increase nums at the index of pi by 1. And for performing this particular operation, we require a cost 1. And or we can choose two different indexes I and j, and we can increase both of these indexes by 1. And this will require a cost of cost 2. Cost 1 and cost 2 value are provided to us in the question itself. So we need to return the minimum cost that is required to make all of the elements of the array equal. What we can do, we can increment the values of the array. We can choose any one index and increment its value by 1. It will require cost 1. Or we can choose two different indexes and increment its value. This will require cost 2. So see, for example number 1, it was 4 and 1. So for making both of the elements equal, what we can do is, we can increment, obviously, we can increment the 1 by 3 steps. It is already 4. We can increment 1 to 4. So we are incrementing only one index. So it will require 5 into 3 operation cost, that is 50. So we will return 50. Second thing can be 2, 3, 3, 3, 5. So the maximum element in this particular nums array is 5. So at least we need to make all the elements equal to 5. Because we cannot perform any decrement operation. We can only perform increment operations. So at least the minimum, we can achieve the equal when all the elements become equals to 5 or can be greater than. So when all the elements becomes equal to 5, how much cost is required? The cost required is 6. What we are doing is, we are incrementing 3 and 3. So it will become 4, 4. It will require cost 2, which is only 1. Then 5, 5. Then cost will become 2. In the similar way, then we can perform for 2, 3. So the total amount of cost required will be equals to 6. So in this way, we will calculate the cost. So see, in this, what we did is, first of all, in the maxi variable, I have calculated the maximum element of the entire array. In the mini, I have stored the minimum element of the entire array. And in the sum, I have stored the sum of all the elements of this particular array. Answer variable I have initialized to the very big value, which is near to int max. And one loop I have done for it, which starts from maxi. Why it starts from maxi? Because to make all the elements of the array equal, so it should be at least equal to the maximum element, right? See over here, it is 1, 4 in the first example. So 1, 4, so at least all the elements should be equals to 4, because we cannot decrement this value of 4, right? We can only perform increment operations. So either all the elements of the array should be equal to 4 or 5 or 6, should be greater than or equal to 4. That's why we have started it from maxi. It is lesser than or equal to 2 into maxi and it I plus plus. This solve function we have made, which will give us the minimum amount of cost for achieving this particular ith value. And in answer variable, we will store the minimum of these two. So see the solve function. This is very important. In solve function, suppose if in cost 2, we can increment 2 indexes. In cost 1, we are able to increment only 1 index. But if suppose cost 1 multiplied by 2 is lesser than or equal to cost 2. If this is the condition, so we can perform only cost 1 operations. For example, if in this particular question, if it is given, see here, cost 1 equals to 2 and cost 2 is equals to 1. So in this, nothing will happen. See over here, in example number 3, cost 1 equals to 1, cost 2 equals to 3. So for incrementing one index, we require only 1 cost. And for incrementing 2 indexes, we require 3. So what we can do, we can increment only one index 1 by 1, and it will be a better option for calculating the minimum cost, because for incrementing 2 indexes, so it will require 1 into 2, which is 2, and cost 2 is requiring 3. So cost 1 is lesser than cost 1 multiplied by 2 is lesser than cost 2. That is why we will use only cost 1. So the very first condition is this one. If 2 into cost 1 is lesser than or equal to cost 2, what we are going to do, we are going to return total into cost 1. What is this total? Total is the number of operations which we need to perform. So total into cost 1. In the max difference, we have stored the difference of the maximum value of this particular array and the minimum value of this array. And we have stored the nums dot size. In total, that is the number of operations that we need to perform. If 2 into cost 1 is lesser than or equal to cost 2, then we are going to return total into cost 1, which I have already explained you. This I will tell you later. You see this particular condition. If cost 2 is less, it means what we need to do, we need to form pairs and then increment these two indexes total. So if total mod 2 double equals to 0, so we will form the pairs. How many pairs will be formed? Total divided by 2. These amounts of pair will be formed and we will multiply this by cost 2. Otherwise, if it is odd, then total divided by 2 into cost 2 pairs will be formed and one operation will still be left. So for that one operation, we require the cost 1. So we will add this cost 2. But what is this edge case? Suppose if the array is equals to 5, 1, 4, and we want to achieve the maximum value as 5. So 5 is already 5. For incrementing the value of 4, we need to perform only one operation. And for incrementing the value of 1 to 5, we require 4 operations. If we want 1 should be equals to 5, it requires 4 operations. For 4 to be equal to 5, it requires only one operation. So we can form only one pair in this particular case. Rest these, for incrementing 1 to 5, only one pair will be formed. Rest for 2 to 5, cost 1 will be required. So this is that particular condition. Total minus max difference. If last is less than max difference, so what we require, only this much pairs will be formed, that is last into cost 2. And for rest of the operations, we require cost. That is max difference minus last into cost 2. So this will give us the minimum cost, this solve function. And at the end, answer will store minimum of answer comma t. And at the end, the question says we need to return the modulo. So we will return answer modulo. So I hope the question is clear to you all. If the question is clear, don't forget to subscribe to our channel and share it with your friends. Thank you.